Hi, it's Tiffany from 1301, and today we're going to go over iteration. So before we go into actual for loops and while loops, let's review the range function because this is used a lot in for loops. So if we have range and we just put one parameter, then this parameter it represents the stop. So automatically the start will be 0, and then the parameter you provide will be the stop. The stop is always exclusive, so this number is not included in the range. So if I list out these numbers, you can see which numbers this range includes. So we can see the range 5 includes the numbers from 0 to 4. This is, like as I said, it starts at 0 if you just provide one parameter, and then it ends at 1 minus that parameter. So let's do another one. Let's say range of 7. This should start from 0 and then go to 1, 2, 3, 4, 5, 6. Cool. Now there's another way we can do the range, and that's with 2 parameters. As you can see here, it says if I have 2 parameters, then a start and then stop. So let's say I start at 4 and I want to stop at 10. I'm going to close that. So what this means is I'm going to start at 4 and I'm going to stop, actually, like my last number will be actually 9 because remember the stop is exclusive. So that's correct. It goes from 4 to 5 to 6, 7, 8, 9. Let's do another practice. Range, let's say -1, 2, 4. Go to -1, 0, 1, 2, 3. All right. And then the last thing is if range has 3 parameters. And if you can see in this doc string, it says start, stop, and then step. So this last optional parameter is actually the step. If the step is not provided, it's automatically just 1. But if we can provide it, we can change it. So let's say I start from 2, I want to go to 10, I want to step by 2. So this means I'm going to start at 2, and then the next number will be 4, and then 6, and then 8. 10 is not included because that stop number is exclusive. Cool, so you see it's 2, 4, 6, 8. And then one last thing is that, your step can be negative, and that just means your start has to be greater than your stop. So let's go from 10 to -2, and let's do -2. So this goes from 10, 8, 6, 4, 2, and 0. And does not go to -2 because the stop number is exclusive. All right, so now that we have this range function under our belt, let's go into the for loops. So why are for loops useful? So let's say I wanted to print something many times. Let's say I wanted to print hello like 5 times. Right now, if I don't know how to do for loops, I would literally have to copy and paste it 5 times. That's not very efficient, right? Because what if I wanted to print it 20 times or 100 times? With for loops, you can do it as many times as you want in just 2 lines of code. So I'm just going to write the function, or the for loop, and I'm going to say for I in range, let's just say I want to do it 10 times. I'm going to print hi. So now in just 2 lines of code, I can print hi 10 times. And so let's break this for loop down. This I is literally just a variable. You could actually name it anything you want. Usually we say I because it usually refers to an index, but it really is just a variable. And range 10, as we can see from earlier, it will go through the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're not actually explicitly using these numbers right now. We're not using I in any way, except for that we're doing something 10 times, and each time we're printing hi. If you actually wanted to see what I is in each iteration, I can print I. You can see that the first iteration I is 0, because that's the first number in the range of 10. And then the second iteration, I will be 1, and then 2, and then until it's 9. So if I run that, you can see that. Yeah, so the first iteration, I is 0. Then you print hi, and now you're in the second iteration, I is now 1. You print hi again, now your third iteration, and so on. So there's also a for loop that can go through each element of some bigger element. So let's say a string. There's a string, and let's say it's Saturday, because today is Saturday. So a string is made up of letters, or characters, right? If I actually write a for loop like this, for letter in A, print A, this for loop is smart, and it just, letter will refer to each individual element in A at each iteration. So in the first iteration, letter will refer to S, and then it will refer to A, and then T, and then U and R. Actually, this is wrong here. It should be letter if I want to print out each letter. If I had it as A here as before, I would just print Saturday 1, 2, 3, 4, 5, 6, 7, 8 times because Saturday is of length 8. But right now I just want to show you printing each letter in the string. So let's see that. Oh, sorry about that. I should probably comment this out. Okay, let's do it again. Yeah, so you can see running this prints each letter on each line. So what this really means, like I said, is that this variable letter is referring to each individual element in this string at each iteration. Also, remember again that letter is just a variable. Just because I name it letter doesn't mean it automatically knows to grab a letter. I can't say like 2 letters. This will not just grab 2 letters. It won't be like S-A, T-U, R-D or anything. This is literally just a variable, and I just named it letter because I know it's going to refer to the letter, and that just makes most sense. So that's also just something to be careful of. And this can also work in lists for any kind of bigger structure. Let's say I have a list and that just has numbers, like random numbers. Cool. And then I want to print each number. I can say for num in B, print num. So if I run that, you can see I do print each number. I go 1, 3, 10, 4, 2. All right, there's actually another for loop that does everything that this for each loop can do, but it can actually do more as well because we use indices. So I'm just going to write this other for loop that does the exact same thing as this for loop, where it just prints each letter in this string. So I'm going to say for I in range length of A, print A at I. So I'm just going to run this to show you that it does the same thing, and then we're going to break it down. So this first Saturday is from the first for loop, and then the second Saturday is from the second for loop, so we can see that these 2 for loops do the exact same thing. So what does this actually mean? This for loop, in this for loop, I refers to each number in the range of 8, because Saturday has 8 letters, and that's what the function length A returns. And then so for each iteration, it's going to print A at the index of whatever I is. So let's say the first iteration, I is going to be 0. And then I'm going to print A at 0, which is S. And that's where we get this first S. And then in the next iteration, I is equal to 1. And if I print A at 1, it gives me A. So it does it for the whole string. But you might think, why would I ever want to use this for loop? It's like more confusing than this for each loop, where the letter automatically refers to, or where the variable like directly refers to each letter. Well, let's say I want to write a function where I can count the number of substrings in a string. So function that counts number of substring in string, and let's say I'm going to say substring equals AAA, and I'm going to say big string equals some random numbers with AAA, random letters, AAA, random letters, AAA. So this function should return 3, right? Because I have 3 instances of AAAs. So let's actually start writing this function. Say def sub count, say sub s and big S. I'm going to say count, initially I count as 0, and then I'm going to say for I in range length of big S, if big S from I to I plus length of sub s equals sub s, I want to increment count, and then after the for loop I'm going to return that count. So let's just run this and see if it does what we want to do, and then I will break it down. Sorry, I want to comment out this region. All right, let's run this. I'm going to say sub count with sub string and then big string. Cool, it does return 3, which is correct. We have 3 instances of AAA. And so now let's actually trace through this function. So I initialize count as 0, right? Because we don't know initially how many substrings are within this big string. And then I'm going to iterate through this big string. So I is actually going to go from, actually I don't know what length of, let's say print length of big string. So yeah, the big string has 23 letters. So this for loop does something 23 times. So I will go through the values of 0 to 22. And I'm going to say if the big string at the substring from I to I plus length of the substring, if that chunk equals the substring, then I want to increment the count by 1. And then after all of that, I want to return the count. So what does this actually mean? If we actually concretely think of the first iteration, I is 0, right? So we're going to say big S, I'm just going to comment it here, big S from 0 to 0 plus length of substring. So the substring is length 3, right? So it's 0 plus 3 is 3. So in the first iteration, we're getting the substring from 0 to 2, right? Because the last number is exclusive. So 0, 1, 2, 0, 1, 2, we're checking these three letters. So we're checking if these 3 letters equals the substring. If it does, then we're going to increment count. And so this makes sense, right? Because if we want to compare these two strings, we know that they're only going to be equal if they have at least the same, length. And then if they're the same length, if they have the same letters, then they are the same. So right now we're just checking each chunk of 3 in the big string because the substring is length 3. So in the second iteration, we know that I is 1, and then substring is always length 3, so now it's to 1 to 4. So 1 to 4 are these 3 letters. So it literally just moves this window forward by 1, and it checks every window of 3 letters, and it compares it with AAA to see if those are equal. And if it does, then it's going to increment count. So that's how this function works. And we can see that in this case, it's really useful to have access to this I, which is just a number, but we use this number to access a substring of this big string. If we were actually using a for each loop, we wouldn't be able to do this because a for each loop literally refers to just directly the number, and there's no way we can access a future letter. So this is where this extra functionality in the for I and range loops comes in handy. So everything you can do with a for each loop, you can also do with a for I and range loop, and in a for I and range loop, you can do even more. That's why sometimes it seemed confusing, but it is indeed very, very useful. So now let's go to while loops. While loops are really useful for when you don't know when you want to stop. So for example, in for loops, we've known that we wanted to print out high like 10 times. We knew we wanted to print out each letter of a string, which is a set length, or like we knew we wanted to compare these substrings for the length of big string. These are all set numbers of iterations. But what if I wanted to keep on doing something until some condition is no longer met? This is when while loops come in handy. So let's say I wanted to write a function that has the user guess what number I have in my head, and if they don't guess it correctly, it's just going to keep on asking them. So let's call this function def guess num. I'm going to take in this n is my guess, and I'm going to say guess equals guess my number. And remember, we're converting it to an int because input always returns a string. So we're going to convert it to an int. And I'm going to say while guess does not equal to n, I want to ask them again. I want to say get int input wrong, guess again. And then if guess does equal n, print congrats, you found me. All right, so let's just run this and see if it works. So let's say I want to guess the number 11. Or I want my user to guess the number 11. So I'm going to guess 1, not correct. 4, not correct. 8, not correct. Blah. Okay, and I'm going to guess 11. Oh, correct, I found it, and now the loop stops. So this makes sense, right? Because we don't know how many times the user is going to guess. We don't know if they're going to automatically guess it on the first try or if it's going to take them 100 times to guess it. So this is where while loops come in handy because we don't know how many times they're going to do it, and we just base the while loop off some condition. In this case, the condition is while the guess does not equal this number n. So if we actually go through this function, we can see we take an initial guess. And then we're going to say while that guess does not equal to the number we want them to guess, then there's going to be a new value assigned to guess, which is their successive guesses. We're going to say wrong, guess again. And then after they guess again, if this guess is actually the correct number, then I'm going to print congrats, you found me. And remember, now guess stores the correct value. It stores the value n, and so when we go back to this while loop, it checks this condition, does guess equal n, and if it does equal n, it's no longer going to go into this for loop because this condition is not satisfied. However, if they don't guess the correct n, it will go back up here and guess still does not equal n, and it will go inside and keep redoing it until guess equals n. So actually, every for loop can be converted into a while loop, but not every while loop can be converted into a for loop because we don't know how many times someone's going to guess this, right? So we can't just encode some for loop with like some number because we don't know what that number is. But the other vice versa is true, where I can convert a for loop into a while loop. So let's try to convert this first function that we did, or this first for loop that we did, into a while loop. So remember, we wanted to print out every letter of this word. So just to remind you, let's print that out. Cool, we see that it prints out each letter of Saturday. So now I want to do this with a while loop. So I'm going to initialize some variable with 0, and I'm going to say while this number is less than the length of the string, I'm going to print the string at that number, and then I want to increment this number. Cool, so we see that it actually does the same thing, right? This is from the first for loop, and then this is from the while loop. So let's actually break this down and see what's happening. We initialize this number, this variable I as 0, and then so while I is less than length of A, and A is Saturday, so length of A is 8, right? So in the first iteration, 0 is indeed less than 8. So I'm going to print A at 0. So A at 0 is S. And so it prints S right here. And now I'm going to increment I by 1, and now I is equal to 1. So 1 is still less than 8, so I'm going to print A at 1, which is A, and then I'm going to continue. So now let's say we're at the end of the while loop. Let's say I is at 7 now, so I is still less than 8. So I'm going to print A at 7. And A at 7 is actually Y, that's the last letter, and that's because, indexing starts at 0. And so, it prints Y, and now it increments I by 1, and now I is equal to 8. And then when it goes back to check the condition again, 8 is not greater than 8, and so it doesn't go into this while loop again, and so it's done. So some of the key things to have when you convert a for loop to a while loop is you have to have some counter or some variable that can be used to check against some other like length of a list or length of a string, and you always want to increment this number or counter to reach a terminating condition. So if I didn't have this increment and I ran this loop would never end. You can see this here. It keeps on printing S, and let me just stop this and explain why. That's because, cool. So that's because I will always be 0. 0 will always be less than 8, and I'm always going to print A at 0, which is S. So that is why it's really important to not forget to increment your counter or whatever variable you're using in the condition, because this way I'm actually, each time I'm getting closer to, making this not true, and so this loop will actually end. To really show that while loops just depend on some Boolean value, I'm going to write a trivial while loop. So I'm going to say while true, I want to, actually let's say I have some number and set that equal to 0. And then I'm going to say while true, number plus equals 1, and then if number is, divisible by 2, I'm going to break. So this example is to, teach you the use of break, because if we actually have this while loop as always true, it's always going to execute and it's never going to stop. So this break actually is a way for us to stop this seemingly infinite while loop. So let's go through and see what it does. So while true, so that's always going to be true, I'm going to increment number. So number is going to be 1, and I'm going to say if number modulus 2 is equal to 0, which just means, if it's, an even number, then I'm going to break. So what break does is it gets out of the loop, and it just continues to whatever's afterwards. So actually, if I had some print here, you can say, I'm outside of the while loop. All right, so this should be printed after it breaks, after it's done with the while loop. So we can run this to see how that works. Oh, actually, let me actually print out this number so you can also see where we are in this while loop. Cool, so let's just trace through it. So number is 0 at first, and then while true, so that's true, number plus equals 1. So I'm going to print number, so I get the first 1. And then I'm going to check 1 modulus 2, that equals 1. So I don't go in, I don't break, and I continue to the next iteration. So this is true, so I continue. Number plus equals 1, so number is now 2. I print that number, I get 2 here. And I'm going to do 2 modulus 2, and that does equal to 0. So I break, and so now I don't go back to here. I actually break, and I get back to here, and I just get to print I'm outside of the while loop. So break is useful to just exit a loop. It can also be used in for loops if some certain condition is met. So let's say I wanted to find a number. Let's say I have a list, or b list equals 1, 5, 8. Right, and let's say I want to find the number 5. So I can say for each in B list, if each equals 5, I want to break, right? So this is kind of a faster way to do things. Like, if you found it, if I found 5, then I don't need to go to the next one because I've already found it. So, I didn't really print anything, so you can't really see much, but this is just an example to show you how you can also use break within a for loop based on some condition if you already found something, or maybe there's other circumstances where you just want to break out after you're done using the for loop. For loops are, as you can see, really, really useful. Just some quick examples of where you can use it is for, let's say, like find max in a list. Let's say I have some list, C equals random numbers, negative, and let's say I want to find the maximum. And so I can literally just go def find max. I have some a list and say, max, current max is a list at 0, right? We're going to initialize the current max as its first value in the list. And I want to say for each in a list, if each is greater than current max, then current max equals each, and then I can return, current max. So we can see what this does. Well, actually, let me just run it first. Let's say find max at C. It should return 234. Oops, I should print this. And I should comment this out. Comment, all right. Oh, I forgot to comment out the first one. Cool, so let me just run that one more time. So we can see it does print 234 because that is the max of this list. So let's go through and see what it does. I first initialize this current max as a first element in this list because we don't know which one is the largest, but we're just going to say it's the first one for now. And then we're going to actually iterate through every single element in the list and say if this current element is greater than the current max, then I want to change the current max to this current element. And after all of that, I'm going to return the current max, which should have the greatest number. So if we just go through this whole thing, we'll say current max is now 1, right? That's how you started out. And I'm going to say if 1, in the first iteration, if each is 1. And I'm going to say if 1 is greater than 1, then I want to change it, but it's not because it's equal. So I'm going to go to the next iteration. Each is now 25. So if 25 is greater than 1, I want to change it. So it is greater than 1. So current max is now 25. So the next iteration, I'm going to say if 234 is greater than 25, then I want to change the current max to 234. That's what we do. And then when we go to the next iteration, 3 is not greater than 234, so we don't change it. And then negative 354 is not greater than 234, so we don't change it. And then we reach the end of the for loop, and then we just return this current max. This can also be done in a for I in range loop. We'll just change that for the sake of practice. I can say for I in range length of list. Remember, we have to do length because range takes in a number. I'm going to say if. So remember, we're now using I as an index. It's a number. It's not actually referring to each value in the list. It's giving you the number from the range. So I'm going to say if a list at I is greater than current max, then I'm saying current max is equal to a list at I. Let's run that. Cool, that's still correct. So hopefully this was some helpful review, and please, leave any comments if you have questions or ask on Piazza.